All right, here's to take a look at that number 11 on the homework assignment. So this one should be similar to what you have. Here we have 9:12 a.m. There's a high tide of 15 feet, and then a low tide that occurs at 3:24 of, oh, I forgot to put it on here, but it occurs at 7 feet deep. I'll put it in there a little bit later. And then it says there's a lunar day that is a full period. So you cycle a full cosine curve that I have here from a height to another height is 12 hours and 24 minutes. So that's what I've marked in there so far. And again, 12 hours and 24 minutes, if you think of it as 24/60ths, then you can get the decimal 0.4. So that's the period, 12.4. And then, so this is all the data. And then it says also that time equals 0 is noon. I'm sorry, 12 a.m. So we're kind of starting the day of Tuesday at 12 a.m. There's the setup. Now the next piece is, there's a couple of questions like the first one. At what time does the first low tide occur? Well, we could just back up from our low tide at 3:24 a full period to the next low tide, because a full period takes you from peak to peak or from valley to valley. So when we have a low tide, a full period will take you back to the next low tide or forward to the next low tide, and vice versa. So if you have a high tide, your next high tide is a full period later. So if we go back 12 hours and 24 minutes, we actually end up at 3 a.m. So that answers that first question. And then the next question, the next things that occur relate to what time certain events or what the high tides are, or the tides are specifically at various times of the day. Well, we just need to model what's going on in this graph with an equation. And we're going to use this basic cosine curve with all the components present, like amplitude and period shift. There's phase shift and period, and then how much vertical adjustment there is up or down. So let's talk first about amplitude. Amplitude is, we have a high tide of 15 and a low tide of 7. Basically, you just need to know where the middle is and then go up or down. So if you can kind of find the middle, you could probably figure out, yeah, looks like it's around 11, so the amplitude's 4. You could eyeball it, but a quick way to do it is find the difference between these two and then divide it by 2, because the top to bottom is double the amplitude. So from 15 to 7, that's 2 amplitudes. What you can do is find out their distance between them, subtract them, and divide by 2, and you get the amplitude. The b is always, remember, that's the part where if you take 2 pi and divide by b, you get your period. We have the period, it's 12.4. So we can do a little equation. 2 pi divided by this b is 12.4. That allows us to solve for b. And if we swap 12.4 in b and then divide by 2, we get pi over 6.2. That's just simplifying. So that's our b. And then h is our shift. Well, 9:12 over there on the left is our first peak that we know information about, our first high tide. And cosine curve really usually starts at 0, 1, or at its peak happens at 0 times 0. Well, this peak is happening at 9:12. We can use that as our shift. That means that we have a graph that shifted right 9 hours and 12 minutes. So we can think of that as and 12 minutes, by the way, is like 1/5 of an hour. So we can think of that as 9.2, just 12/60ths is also 0.2. Our graph, the peak, is occurring at 9:12 instead of at 0. That's a shift to the right of 9.2. So we can take that h, that horizontal shift component, make it 9.2. And finally, the up shift, well, we have an amplitude of 4. So if we take 15, the high tide, down 4, we get 11. If we go from the low tide of 7 up 4, our amplitude, we get to 11. That's one way to look at it. Or you can just do the average of 15 and 7, the high and low tide. That'll give you the vertical shift as well. So I could just add them up, 15 and 7, and divide by 2. That's the average, would also give you that adjustment. So it's 11. So here they all are. If I put them all back in place, 4 cosine of pi over 6.2, all times x minus 9.2, and then add 11. We're supposed to find out various times of day what the actual height of the water is. So let's say at 4 a.m. you put 4 in for t or x, or I think I probably used the wrong variable a couple times. If you want 9 a.m., it'd be 9 going in for x. If you wanted 9 p.m., it'd be 21 because it's 12 plus 9. So you have to make sure you put in the appropriate time to answer that question. I think the rest falls into place. Let me know if you have other questions.